Okay, whether screen is visible to all?
Yes, sir.
Okay, okay, fine. Um, Very good afternoon to all. Um, as in last semester, I personally deal with electrical machine 1 as well as machine 2. Right. So now, as a part of advanced technical training, as a part of ATT, again I am dealing with DC machines. So in that, I will I will teach you about the DC motor and what kind of questions, what kind of uh, numericals, what kind of theoretical questions, as well as some problems can be asked for the gate examination. Okay, so that we will discuss. So before going for the syllabus, or I can say before going for the major numericals, we'll see whether little bit few theoretical overview we will take, and after that we will go further for the whatever our numericals will be there. So as we know that about the DC motor, that motor is based on the principle as who will tell me the working principle of DC motor? Anybody? When a current carrying conductor placed in a magnetic field, a mechanical force is being experienced by the conductor. And so whatever the direction will be there, that will be defined by the Fleming's left hand rule, right? So this is the operating principle of DC motor. So now you will ask me, sir, whether in the gate examination like that operating principle will be asked. Just take in mind that whatever the questions asked in a gate examination, that will be the tough. But for going for this tough questionnaires, you have to clear your basic concepts, right? So here is the basic concepts like operating principle you must know, and again the back EMF. So what is the back EMF? Means whenever your DC motor will start to rotate, at that time whatever the fluxes are there, or we can say magnetic fluxes are there, whichever produced by the our field winding, that can cut by the armature conductors, and whenever that armature conductor will cut these fluxes, then EMF will get induced in that armature conductor, and that EMF is known as a back EMF. So what is the function that back EMF? That back EMF is always opposes to the applied voltage. That opposes to the applied voltage, right? And the equation for this EB, that back EMF, is nothing but already we had seen in machine, but here we only recall the equation, that is P N phi Z divided by 60A, where P stands for the number of poles, N stands for the speed, Z stands for the armature path, phi stands for the fluxes, and A stands for the parallel path, right? So that can be written as a Ka phi omega m. So that Ka we had studied as a constant value, right? So this is the basic overview we are seeing. Just then again for the EMF equation. So in EMF equation, V is equal to EB plus IRA. Okay. So that V is nothing but what? It is applied voltage. This IA is armature current, RA is armature resistance, EB is back EMF. So all that things are known. So whenever for this V is equal to EB plus IARA equation, once we will multiply by IA to every side, okay, here I will multiply by IA, here I will multiply by IA, so it will become IA square RA. So V into IA, that will become a V into IA, that will become a input power, that will become input power. Then IA into EB, back EMF multiplied by armature current, that is nothing but what? That is power developed at output. And whatever the I square array, that is we know that I square array is a ohmic losses. Okay, so depends on that there will be the I can say there is a torque equation which is nothing but output power by angular speed. So we can derive that EB into IA divided by omega m. So again that EB we can replace by the phi phi z and P divided by A. So once we will solve that one, we will get the value that is Ka into phi into Ia. So from that equation we can understand for the shunt motor our torque is directly proportional to the armature current. Why? Because our fluxes are constant. But in case of series, our fluxes are directly proportional to the Ia. So Ia fluxes Ia and this Ia that will become Ia square. So you will get the torque is directly proportional to the square of armature current in case of a DC series motor. Okay. So we are not going further into deep. Okay. So we are just taking overview as already we had completed whatever the theoretical part in a machine 2, machine 1, right? So then next one will be the characteristics of the DC motor, that is nothing but speed torque, then speed armature, torque armature. So as already we know that in DC shunt motor, whenever our field winding is connected in parallel with the armature winding, then it is known as a DC shunt motor. So again there is a shunt winding, then rotor, commutator. So function of everything we had seen. So as I told you, there is a speed armature torque. So as we know that I torque is directly proportional to the Ia in case of the shunt motor, and in case of the series motor torque is directly proportional to Ia square, right? So already we know that our speed is directly proportional to the phi upon EB, to the phi upon EB, or we can write in another way, like that way. See, in case of the series, so as we know that torque and speed, so already we know that our speed is inversely proportional to the EB, okay, and our speed, whatever the torque is there, that torque is directly proportional to the Ia square in case of the series. So whatever the diagram will be there, that will be like that way. Okay, sudden change, right? Okay, so here you can see there is the characteristics. Okay, that means whatever the current is increasing, that will be the square of, okay, armature current. So by this way we can just solve the all things, right? Then next we can see about the this speed and back EMF. So as we know that this EB is nothing but inversely proportional to the speed, so we can say that we can write 1 by phi. Okay, so n is inversely proportional to the I am Amay Kumar, am I audible?
Yes, sir.
Okay, thank you. Okay, actually, I lost my internet. Okay, fine. So here we are again back to the point. So, Amay Kumar, at what point I was clear? My voice was clear. At till what point? Yes. Can you tell me at which point I was audible?
You, sir, you just started.
This 3 point starter.
Uh,
Okay, fine. Okay, thank you. So again, we will continue this point. So here in 3 point starter, as we know that there is a L, F, and A in three terminals, that is line, field, and armature, right? So in these three terminals, as we know that L is connected to the overload coil, which is connected in series, and again this rod is placed at the spring, and multiple resistances which are connected in series like that way. So however you just move your knob to this side, that time at one by one resistance will get out of the circuit, right? So this is the important thing in case of the 3 point starter. Okay, so that again at the another end there is the NVC, that is no voltage coil. So whenever there will be a no current flowing through this rod, at that time this rod will just destroy whatever electromagnetism available at this NVC, and then this NVC will release the rod, and that is why then again it will comes to the off position. So that means your motor will get off. Okay, so this is the simple working principle of the 3 point starter, right? Then next part that is we will study is speed control of DC motor. So various methods are there. So fastly we will see one by one. So here in the voltage equation, as we know that V is equal to EB plus IRA. So we can rewrite that equation with the help of just substitutions of AB is equal to B minus IRA. So that EB already we know that Ka phi omega m. So is this omega is nothing but what? That is the speed. So this we can manage. See, first thing, if suppose all other things are constant and we will change the voltage, that means our speed and supply voltage, both things are what we can say, both things are proportional to each other. Okay, so this is the first method that we can say by changing the voltage. Second thing that we will consider that numerator side is a constant, and that fluxes. So we can say that by changing fluxes we can control the speed. And third thing, that is this armature resistance. Okay, so once we will change that armature circuit resistance, by changing that one also we can vary the speed, right? So there is a three types as the flux per pole method, that varying flux per pole method, then varying resistance of armature circuit, and varying applied voltage. So these are the three types. So based on these three type of controlling of a DC motor, we can see for the shunt motor here, as you know that by armature resistance method, means the armature resistance is inserted in series with your armature circuit. Okay, so by using the variable resistance or rheostat, we can vary the resistance. So once we will vary the resistance, that means your current will change. So once your current is going to change, then the whatever the speed is there, that will also affect. So whenever we want to achieve the speed whichever below the rated speed, that time this method is sufficient. Then again we can see in case of series motor that rheostat is already connected in series with the armature circuitry, and that with the help of this rheostat we can control the speed of induction DC shunt motor. Then in case of series motor, as I already told you, the terminals are just connected in series. Okay, so whatever the current is there, that can be controlled whenever your circuit, whenever your rheostat will be connected in series, right? Then varying flux. So how we can vary the flux? So whatever the current flowing through the field winding, no, that if we plan to change, or that if we plan to control, then obviously the control of this current can also vary the fluxes. Okay, so if we reduces the field current, that means your fluxes will going to decrease. So that is about the series motor, right? Sorry, shunt motor. And about the series motor, here also as shown in the figure, that where is a diverter also we can say the resistance or rheostat that is connected there also, right? So with the help of these resistances, we can vary the field current, and with the help of field current, we can say there will be the field flux variation, right? So once our fluxes will be maximum, speed will be minimum, like that way, vice versa. Okay. Then in case of the armature terminal control terminal voltage, in armature terminal voltage, what we will do, we with the help of the motor generator set mg set, what we will do, we will just couple our motor with a generator, and with the help of this excitation which are provided to the field winding, with the help of this one, we will fed the supply to the motor by using the generator. Okay, so how it will change? So if our base speed is like that way, where we can control the armature voltage at that time, your power will be the maximum value. So however, we will just start to increase the speed. That time what happens, your torque will be decreased, and that time we can say that that is nothing but what, speed control, which can be able to um, speed control which can be easily available for the both directions, right? Just a minute. Okay, so please make sure whether it is visible.
Yes, sir.
Okay, thank you. Okay, fine. So this is the about speed control by varying the we can say terminal voltage. Okay. Also, we can use a very controlled rectifier. So already we know that what is the rectifier. The rectifier means what? The device which converts AC into DC. So this method is also known as it is similar as a Ward-Leonard method. So in case of whatever recently we had seen in that method, in Ward-Leonard method, what we had seen there is MG set, and that set is used to convert AC into the DC. And in this current system, instead of this MG set, we are directly preferring controlled rectifier used to supply the DC supply. So that that is economical, and as this costing is very less, as there is no need of DC generators and amps motor sets. Okay, so this is the also useful and efficient method which can be used to control the speed of DC motor, which will be the below base speed or rated speed. Then second is the series parallel armature control. So in that method, armature control requires two identical DC motors. It requires two identical DC motors which are coupled to each other. Okay, so that coupling is nothing but what? That will be the mechanical coupling. Okay, so that coupling is almost necessary in case of the our DC motor. So once that DC motors both are connected or both are coupled to each other mechanically, then what we can say? We can say that whatever the speed control is there, that can be brought to the rated speed or around rated speed. Okay. So this is all about the theoretical overview we had just gone through. Okay. So now we will move towards the few numericals. Okay. Just hold. Okay, now it is necessary that you should take a pen and notebook. Okay, all of you, notebook and pen is with you. Okay, now tell me whether it is visible or not. Fine. Is it visible clearly? Yes, Sagar. Is it visible? Kame, is it visible?
Yes, sir.
Yes,
Yes,
just
sir.
read the example. Kame, read the example.
A 220-volt, 15 kilowatt, 1000 RPM shunt motor.
Okay, Ame, please continue. Hello? Ame, am I audible?
Yes, sir.
Yes, please continue and try to solve this example. Okay, just try to solve.
A 220-volt, 15 kilowatt, 1000 RPM shunt motor with armature resistance of 0.25 ohm has rated line current of 68 ampere and rated field current of 2.2 ampere. The change in field flux required to obtain a speed of 1600 rpm while drawing a line current of 52.8 ampere and a field current of 1.8 ampere is.
Okay, how many of you solved? How many of you solved? I'll read once. A 220 volt. Just understand what is given. A 220 volt, 15 kilowatt, 1000 RPM shunt motor with armature resistance of 0.25 ohm has rated line current of 68 ampere and rated field current 2.2 ampere. Change in field flux required to obtain a speed of 1600 rpm while drawing a line current of 50 to 8 ampere and a field current of 1.8 ampere. Now, this is the question which are asked in a GATE examination 2012, 2012. Okay. So now, from this you have to solve. Okay. So tell me, what should we have to do? कसं solve करता येईल सांगा पाहू. What will be the first step? Yes, speak up. बोला, toppers. Solve करता है का? Am I audible? Am I audible? अरे माझा आवाज येतोय का? Anmol, Arti Doble, Ashwini. Okay, if you are not responding, I'll just remove you from the meeting. Anmol, am I audible? Bhattare Rushikesh, am I audible? Am I audible?
Yes, sir.
Now am I audible?
Yes, sir.
कितीदा विचारायचं म्हणजे माझी परीक्षा घेताय का तुम्ही लोक? हा 25 वेळा झालं माझं ओरडून. एकाची अटेंडन्स लावली जाणार नाही, लक्षात घ्या. आता जस्ट यू हॅव पास द सेकंड इयर. ओके, 5-6 times I have asked whether I am audible or not. There is only 2 words, yes or no. Fine, I'll just complete whatever syllabus is there. Okay, I don't care whether you people are taking from that anything or not, because I think you are irresponsible. Behavior is irresponsible by yourself. Fine. So this is the question, and in that question it has given that armature resistance 0.25, which is written here. Then field current 1, that is given 2.2, and another field current is given, that is 1.8 ampere. IA1, that is given 68 ampere, and that is 68 ampere is nothing but what? Line current. Okay, that is line current. But as we know that in case of DC shunt motor, IA is equal to, what is the equation? As we know that IL minus ISH or IF. So IL is a 68 minus ISH is 2.2. So for that one we calculated IA1 65.8, and IA2 similarly we had calculated it like, again similar like a 51 ampere. So now we will calculate first of all EA1 and back EMF for another X given value. So for the first 220 minus that IA is a 60.8 and the resistance is 0.25. The resistance will be the remain same. So it's 203.55 volt and 207.25 volt. That is nothing but what? That is the EMFs. Okay. So then what will be the next? The next we know that there is a equation EA1 divided by EA2 is equal to phi1 by phi2 into omega m1 by omega m2. So now first important thing, EA1 we have calculated, EA2 we had calculated. So we have to take these two values. Phi1 and phi2 will keep as it is. Omega 1, omega 2. Here is given omega 1000, omega m2, that is the 1600. We will take that value. Now phi1, phi2. So what is the relation they had given? The change in field flux required to obtain a speed of 1600 rpm. Okay, so as they told us, what is the given value? That whatever the values are there, we have to find out this phi1 by phi2. So we will calculate this 1600 will goes to this side, this 1000 will goes to divide. Okay, so with that manner we will find out the values. Okay, so now once we will find out this value, then we will come to know that phi1 by phi2 is equal to 1.571. So now the question is change in field flux required. So we have to calculate change in flux required. Okay, so here we will calculate that percentage change in flux. So suppose we will consider that first will be the phi1, पहले flux kiti phi1, another flux will be the phi2. So how we will calculate change? Another minus previous, another minus old, that is phi2 minus phi1 divided by old one, that is phi1. Okay, so is equal to, how we will calculate? We have to place this phi1 as a something value we have to change. So what we will do? We will change that phi1, we will write as phi1 is equal to 1.571 phi2. and this value we will put in this equation, then we will get minus 36.36. So that minus is nothing but what? That means if there is a plus, that means increase. If there is a minus, that means it is a decrease. Okay, so this is known as a 36.36. There is two options. Okay, these two will get cancelled because there is 18, but there is 36.36, there is 36.36. So here is symbol minus, so that is why it is nothing but decrease. So answer D will be the right answer. Okay, so this is the first example we had seen. Another example we will go for, that you have to solve. Preeti, read the example immediately.
A 220-volt DC shunt motor is operating at a speed of 1440 rpm. The armature resistance is 1 ohm and armature current is 10 amperes. If the excitation of the machine is reduced by 10%, the extra resistance could be in the armature circuit to maintain the shunt speed and torque would be.
Yeah, so 220 volt is a voltage given. At speed again 1440 is given. Armature resistance given. Armature current is given. Now the excitation of machine is reduced by 10%. So the extra resistance to be put, that means we have to calculate extra resistance, right? So let us go for the solution. Okay, first case, we'll see the first case. Armature resistance given 1 ohm we had taken here. Armature current 10, speed 1440, voltage 220. So from that we will calculate the back EMF. So Vt minus 220 minus Ia1 Ra into bracket. This time we had considered external resistance is a 0. Okay, so now from that we got the 210 volt. Okay, so this is the first case. In that case, what we have got? We have got 210 volt a back EMF. So now second case, that back EMF is told that excitation of machine is reduced by 10%, means that will become 90. That will become 0.9. Okay, 10% is reduced. That means it will remain 90. So we will get the another new flux is phi 2. That will be the 0.951. So speed will be same. Okay, the speed will be same because to maintain the same speed and torque, means speed and torque is the same. Okay, so speed is constant. So from that equation we know that EA2 is equal to phi 2 by phi 1 into EA1. So phi 2 value is nothing but 0.91. Here phi 1 got cancelled. So another back EMF we will got EA2 is equal to 189. Then again, as we know that they had told us torque will be also same. So for that again, torque is directly proportional to the phi Ia, but here in case we as we know that the torque is a constant, so we will take as it is. So we know the value for the torque 1, that is phi 1 Ia1, and for the torque 2, that is phi 2 Ia2. So again Ia1 and Ia2. Now here the Ia1 is known value. Phi 1 we will write as it is. Phi 2 is again known value 0.951 and Ia2. So phi 1 cancel. Ia2 will become 11.11. Okay. Then the next point, that is we got the value of EA2, we got the value of Ia2. We have the value of armature resistance, so we can calculate external resistance easily. Okay, so what is the formula? EA2 is equal to terminal voltage minus Ia2 into bracket Ra plus external resistance. So at this point, external resistance has to be calculated, right? So as we don't know the external resistance, we will take as it is Rext. So all other values, that EA2 here we got the 189, the terminal voltage already we know the 220 volt, 11.11 Ia2 here we had calculated, Ra they had given us Ra, that is the 1 ohm. So from all these solutions, what we will get? We'll get the external resistance 1.79. The right answer will be the option A. The option A will be the right answer. Okay, so here is there any doubt? Speak up immediately. Is there any doubt?
No, sir.
Okay, fine. So this is the example. So like that example has been asked to the examination. Okay, now Shreyash, are you there? Shreyash? Okay, who will read? Snehal?
Yes,
Yes,
sir.
read the example.
A 240-volt DC shunt motor draws 15 ampere while supplying the rated load at a speed of 80 radian per second. The armature resistance is 0.5 ohm and the field winding resistance is 80 ohm.
Fine. So a 220 volt or 240 volt DC shunt motor draws a 15 ampere while supplying the rated load at speed of 80 radians per second. Armature resistance is a 0.5 ohm and the field winding resistance is a 80 ohm. So the questions are below. Read Snehal, read first question.
The net voltage across the armature resistance at the time of plugging will be.
So first question is what will be the net voltage will appear across the armature resistance when we will do the plugging. Okay, and the second question, that is external resistance to be added in the armature circuit to limit the armature current to 125% of its rated value. So from this given data they had asked us two questions, so now it is our duty to solve these two questions. Okay, so who will help me to solve? Who will tell me how to solve, how we can move further? First, so first thing, that is field current. We will calculate field current. How we will calculate field current? As we know that this is the DC shunt motor, right? So this is the field. Okay, this is the armature, and this is our supply. Okay, we will consider like that way. So here we know that there is a ISH, here is a RSH, here is a V, RA, current flowing IA, and here is a IL. Okay, so IA is equal to IL minus I. So now here voltage we know that this is the 240. This resistance we know that that is the 80. As I told you in lectures that here is the same voltage, so we can calculate ISH. What will be the ISH? Tell me. What will be the ISH? That voltage divided by resistance. बरोबर का? So voltage is 240, resistance is 80. So IF will be 3 ampere, right? And as we know that how much current they had given, they had told us that it draw 15 ampere. 15 ampere means it is a load current. So 15 ampere is load current, 3 ampere is a shunt current. So what will be the armature current? Yes, what will be armature current?
Load
See,
current minus field current.
yes, that is nothing but 15 minus 3, that will be 12. Okay, now we know the value of armature current, armature resistance, we know the voltage. Who will tell me the back EMF? Back EMF is equal to voltage minus IaRa. Tell me. Calculate immediately. Voltage is 240 minus Ia is nothing but what? 12. Ra is nothing but what? 0.5. It is a oral calculation, that will be around 234, right? It is around 234. Am I clear?
Yes, sir.
Okay,
Yes, sir.
now we'll move forward to whatever the connections of armature winding. So whatever diagram right now I had drawn here. So in this diagram you can see the plugging. Plugging means what? The connections. That connection will come to this point. I'll show with another pen. That connection will comes to this one. Okay, this is connected to this one, and this end will be connected to the this side. Okay, so that means connections will be reversed. That is nothing but plugging. Okay, plugging is nothing but what? Plugging is a reversal in a connections. Which connections? That armature winding connection. Okay, so whenever that connections will be changed, so that means what happened? That means whenever we will change the connection, the whatever the braking torque will be there, that will be achieve a main, that will achieve maximum. Why? Because while we are doing a reversal in connection, that why it needs to maintain the supply voltage whatever given to the armature. So that's why that strong braking torque will be achieved. Okay, so that braking torque will, what it will does, it will just add the voltages. So whatever the armature resistance will be there and voltage appears across this is nothing but what, whatever the voltage is given plus AB. So that voltage plus back EMF is nothing but what, it is the answer of first question. Answer of first question will be whatever the voltage is there and whatever the back EMF is there, addition of these two will be equal to the your total voltage appears across the armature current, armature resistance. Okay, now what will be the second question? What will be the second question? The external resistance to be added. Second question is external resistance to be added in the armature circuit to limit armature current of 125% of its rated value. So first of all, we have to calculate what is the armature value, armature current value. So already we know that the armature current value is a 12 ampere. Okay, so from that, whenever we will apply the braking at that time, as they told us, that will comes to the 125%. So what we will do, we will calculate 125% of this armature current. So 12 multiplied by 125%, that is 1.25. So that current will be, that means during the braking the current will becomes equal to the 15 ampere. Is that clear? Now we have to calculate braking resistance. So that braking resistance is nothing but what? Braking resistance means armature resistance plus the external resistance whatever we are inserting, right? So already again we know that instead of this RA plus RXT, we have to calculate RB. So how it comes? As we know that V IA RB. Okay, IA RB. So that RB is nothing but what? RA plus R external. Right. So with that note, EB plus V, that is nothing but 240 plus EB we had calculated 234, that is nothing but 474 divided by I dash, that is 15. Okay, so your resistance RB, that is RB, braking resistance will be 31.6. But whether they had asked us braking resistance or whether they asked whatever the armature's resistance, whatever the external resistance is to be inserted into the armature circuit. So they had asked a value of external resistance to be inserted into armature circuit, right? So the whatever value we are calculated here, that is around braking resistance. So once we will subtract the armature resistance from this braking resistance, then we will get the external resistance. So 31.6 minus that 0.5, that is nothing but armature resistance. So you will get the 31.1 ohm resistance has to be added into the armature circuit to limit the armature current of 125%. So that is the answer. So here answer D and here answer A, that will be the clear answer, and once you will complete that one, you will get 4 marks. Okay, so that question was asked in a 2008 GATE examination. Okay, so now I'll give you one assignment homework question. Just take a screenshot of that one. Yes, a 220 volt DC shunt motor runs at 500 rpm. When the armature current is 50 ampere, calculate the speed. If the torque is doubled, given that armature resistance is 0.2. So speed काढायचा आहे, torque when your torque will be doubled. So I hope you have taken a screenshot. Okay. So I'm ending the PPTs. Okay. So we'll come back to the screen. Okay, now I am enabling all to message. So all should write your roll number into the chat box. Whatever new roll numbers has been assigned to you, like that way you should write your roll number and leave the class. immediately. So better to start from roll number 1, 2, 3, 4, 5. Like that way, you just type your roll numbers into chat box immediately. Yes, roll number 2, 3, 4. I am not going to announce every time. Okay. Within 2 minutes, I am going to end the meeting. So those who will write there, that their attendance will be considered. Otherwise, absenteeism will be there. Those who have given attendance can leave the class. Okay, last 10 seconds. Last 10 seconds for the attendance. Okay, last 5 seconds. Within 5 seconds, I'm going to end the meeting. Don't message me once meeting will be closed. Okay? नंतर मेसेज करू नका माझी अटेंडन्स राहिली वगैरे. जे मेसेज टाकतायत त्यांची अटेंडन्स कन्सिडर होईल. अदरवाइज जे नाही टाकत आहेत आय विल कन्सिडर दॅट दे हॅड kept a mobile and they went anywhere. Okay, last 5 seconds. Anmol, Ashwini, Sagar, Suraj, Shivsharan, Anil, Vibhute, Kiran, Vaidande, Vrishali, update your attendance in chat box immediately. Okay, fine. Closing the meeting.